So now the overview of Euclid division lemma. First thing is it has to do with division with remainder. So let's understand the heading itself. We have the word Euclid. It's a person's name. Division, it's an operation. And then we have the word lemma. Lemma means it's a minor result. It's something that you observe. No? Right? It's easy to observe and you can make a conclusion based on that observation. Right? It's an observation, minor result. It's an observation. Assumed to be true for all the scenarios. And that is used as a stepping stone to prove something bigger. So you observe something, right? You repeatedly see that, then you come to a conclusion that yes, if this is so, this will happen. Example, if I take any even number, right? If I take any even number, divide that by 2, right? And I'll get a remainder of 0. Is it not? So this is an observation. Right? Based on this, I can prove different things that you will be looking at in the chapter. So you will understand the word lemma better. So I've here defined what is division itself. It's not required, but anyways, division with remainder is a set of steps where we are dividing one integer by another, and they get the quotient and the remainder smaller than the divisor. So the word smaller over here is important. Based on this, we have a lot of proof. So now, next thing is, mathematically, how does Euclid division lemma look like? So I have division over here. Let us divide that first. 25 dividing this. What do we get? Well, we have the quotient as 4. Hundreds are, on subtracting, we are getting 3. So here we are looking at, that's your divisor, dividend. 103 is your dividend. This is your quotient and that's your remainder, is it not? Right? So I can rewrite 103 as 25 into 4 plus 3, is it not? 25 into 4 is 100 plus 3 is 103. So based on my division, I was able to rewrite 103 in a different form. So Euclid division lemma has to do something with this, right? So you'll be looking at few more examples, then we'll conclude. Again, the topic is a bit weird, but you'll get used to in time. Now, we are dividing 22 by 4. Quotient is 5, this is 20, and the remainder is 2. Right, this is your remainder. That's your quotient, divisor, dividend. Right? So again, how can I write 22 as? Right, 4 into 5 plus 2. Is it not? Divisor into quotient plus remainder. Right? One more example. I'm dividing 26 by 6. So we have 6, 26. So if we continue this, you'll get 6 4s are 24. And the remainder is 2. So again, divisor, dividend, right? I'll call this as A, B, quotient as Q, and the remainder as R. Right? So I'll be able to rewrite 26 as 6 into 4 plus the remainder. Make sense? So in general, right? In general, how can I write all of this process as? Well, I can write it as A, right, is equal to B, which is your divisor, into the quotient plus a remainder. any number which is getting divided by some number b, we can obtain back the number a by multiplying with the quotient and then the remainder, right? So one important conclusion is that remainder is always lesser than the divisor, is it not? So when do we stop dividing? If you remember from your childhood days, you stop dividing when the remainder is lesser than the divisor, is it not? You should do that till you get a 0 or 1 or 2 in your maybe 4th grade, I guess, right? I don't remember it exactly which grade this will be taught. This has been taught. So this is the basic idea. So Euclid division lemma looks like A is equal to B into Q plus R, where the remainder can be 0 or greater than 0, but always lesser than the one which is dividing. So this is your Euclid division lemma. This is how it looks like, right? It's all to do with division being written in a fancy way, that's all, right? So the next thing is your fundamental theory of arithmetic. I think we'll do that in the next video.